Okay, so now I'm going to talk about dipole-induced dipole. Dipole means polar in nature, which means it has charges, and induced dipole means it's non-polar. It has been made dipole, induced dipole just because of this dipole molecule, right? Let's take an example of this dipole-induced dipole. For example, in dipole means let me take an example of HCl. Again, let's take example of HCl molecule. Hydrogen chloride, right? So induced dipole means non-polar. So that we can example of, for example, oxygen. Let's take an example of oxygen here, or chlorine or anything. Let's take an example of chlorine. So this is induced non-polar molecule, chlorine molecule in diatomic form. When this chlorine molecule attracts this chlorine molecule, so this chlorine molecule gets the partial positive charge, and this chlorine molecule gets the partial negative charge. It has negative charge, it has positive charge, partial positive, partial negative. So when this chlorine molecule attracts with this chlorine molecule, so it gets the partial negative and partial positive charge. So this is basically known as dipole-induced dipole. Previously, this chlorine molecule was a non-polar. Why? Just because first reason behind it is that their electronegativity difference is 0. No ion, positive ion or negative ion exists between them, or it was not electrostatic in nature, right? No, it was not electrostatic. But what happened? Oh my God, it's looking such a messy, but still we can ignore it, right? So let me just take it here. I hope I can explain with that of this picture. Let's bring it. Light color so that everything will be visible to you guys. Let's take the example. This is hydrogen atom. This is chlorine. And when this chlorine attracts with this helium molecule, maybe it should be in diatomic form. Helium, for example. So this helium molecule gets the partial positive charge. This helium gets the partial negative charge. When the chlorine attracts what itself. And what this arrow is showing? This arrow is showing a movement of molecule from the less electronegative to the more electronegative. As you can see that hydrogen is less electronegative and chlorine is more electronegative. So we can read this definition here as well. Like, what is induced dipole? An induced dipole is a temporary dipole moment that is created due to the influence of the neighboring dipole molecule, this dipole, which can be permanent or an instantaneous dipole. Instantaneous for a time interval, for a t time interval. So let's write it. Then I'll be discussing as well what is instantaneous dipole interaction in this video. Instantaneous means for a time interval, for a very short time interval, for a time interval. Which means temporary dipole for t time for a time interval. I think so there is a need to write it. So I'm writing. Or it's difficult to write with this pen. For a time interval, right? So let's discuss the other one, which is instantaneous dipole-induced dipole, which is also known as London or dispersion forces. So now I'm going to talk about the next one, which is instantaneous dipole-induced dipole, instantaneous dipole-induced dipole or London dispersion forces. Now, what does mean by this? Let's take an example. Instantaneous mean for a time interval, dipole mean has a polarity, and induced dipole mean is non-polar in nature, right? What does mean by instantaneous means? Let's write it. Instantaneous, maybe the spelling is not right, that you can check by yourself. For a time interval, for a very short time interval, and dipole mean have polar, induced mean non-polar. So this is basically, let me just draw it. Take an example of any dipole, instantaneous dipole, induced dipole, right? For example, let's take example of two molecules. No.